Structure 1, the Dyson sphere. This is the one that started the conversation about megastructures seriously. A Dyson sphere is a theoretical shell built completely around a star, capturing every photon of energy it produces. Physicist Freeman Dyson proposed it in 1960, not as science fiction, but as a genuine engineering possibility for a sufficiently advanced civilization. His argument was simple. If a civilization keeps growing, it will eventually need more energy than a planet's surface can collect. The logical solution is to go to the source. A full shell around our Sun would need to be built at roughly Earth's orbital distance, about 93 million miles out. The surface area would be approximately 550 million times that of Earth. The material requirements alone are staggering. You would need to dismantle every planet in the solar system just to gather enough mass. A partial version, called a Dyson swarm, millions of individual solar collectors orbiting in formation, is considered far more realistic. In 2015, a star called KIC 846-2852 showed bizarre flickering patterns that briefly led astronomers to genuinely consider whether something like this had been built around it. It turned out to be dust. Probably. Structure 2. The Ringworld. Larry Niven introduced the Ringworld in his 1970 novel of the same name, and engineers have been stress testing the idea ever since. A ringworld is a massive ring built around a star at habitable distance. Instead of a sphere, it's a band, rotating fast enough that centrifugal force simulates gravity on the inner surface. Niven's version had a radius of roughly 93 million miles, a width of about 1 million miles, and a surface area equal to approximately 3 million Earths. The structural requirements are beyond anything we can currently imagine. The material holding it together would need to withstand tensile forces that no known substance can handle, something called skrith in the novel, which Niven just invented because nothing real works. The rotation speed required to simulate Earth gravity would be about 770 miles per second. It's one of the most beloved concepts in science fiction precisely because the engineering problems are real, specific, and genuinely unsolved. Structure 3. The matrioska brain. A Dyson sphere captures energy. A matrioska brain uses it to think. The concept, proposed by Robert Bradbury, is a nested series of Dyson spheres, each layer capturing the waste heat from the layer inside it, all dedicated entirely to computation. The entire energy output of a star converted into processing power. A computer the size of a solar system. What would you compute with that? Simulations of entire civilizations, models of the universe at perfect resolution, uploaded minds running at speeds millions of times faster than biological thought. A matryoshka brain operating at full capacity would be so far beyond human intelligence that trying to imagine its thoughts is like an ant trying to imagine a symphony. It is the logical endpoint of both energy collection and artificial intelligence, taken to their absolute extreme. And the physics, as far as anyone can tell, doesn't prohibit it. Structure 4. The Banks orbital. Banks introduced this in his culture novel series, and it solves several problems the ring world doesn't. An orbital is a smaller ring, not built around a star, but free-floating in space, angled to catch sunlight on its inner surface. The radius is much smaller than a ring world, typically around 1 to 3 million miles, making the structural demands significantly more manageable. It rotates to simulate gravity, tilts to create day and night cycles, and the inner surface is fully habitable. Oceans, mountains, weather systems, and all. The elegance of the orbital is that it isn't trying to be as large as physically possible. It's trying to be as livable as possible. Banks wrote it as the preferred habitat of a post-scarcity civilization that had already solved most engineering problems and simply wanted somewhere pleasant to exist. The design reflects that priority: comfortable, functional, and only mildly civilization-ending to construct. Structure 5. The stellar engine. What if you didn't just want to harvest your star's energy? What if you wanted to move it? A stellar engine is a theoretical megastructure designed to accelerate an entire star through the galaxy, dragging its solar system along with it. The most discussed version is called a Shkadov thruster, a giant mirror positioned on one side of a star, reflecting radiation back and creating an asymmetric push. Slowly, over millions of years, the star moves. The reason a civilization might want to do this ranges from avoiding a nearby supernova to navigating toward a more stable region of the galaxy. The speeds involved are extremely slow by cosmic standards. Moving a star meaningfully would take millions to billions of years. But on a long enough timeline, with a patient enough civilization, it works within known physics. It is one of the few megastructures on this list that requires no exotic materials and no new science. Just an enormous mirror and an enormous amount of patience. Structure 6. The Alderson disk. A ringworld is a band around a star. An Alderson disk is a flat disk, like a vinyl record, with the star sitting at the center hole. The disk would extend from roughly the orbit of Mercury out to the orbit of Mars, giving it a habitable surface area of trillions of times that of Earth. The star sits in the middle, providing light and heat to the inner edges. The outer edges would be cold and dark, essentially permanent winter the further out you go. The structural problems make the ringworld look simple. The gravitational forces involved would tear the disk apart without materials of impossible strength. The star in the center would pull everything toward it unevenly. There's no clean rotation solution that creates uniform gravity across the surface. It's considered one of the most structurally implausible megastructures ever seriously proposed, which in this field is a real achievement. It gets included not because it would work, but because the scale of it is almost incomprehensible, and that alone earns it a place on the list. Structure 7. The nickel Dyson beam. A Dyson sphere built around a star collects enormous energy. The nickel Dyson beam points that energy in one direction. Essentially a weapon or a propulsion system, depending on your intentions, the nickel Dyson beam focuses the full output of a star into a directed energy beam. At full capacity, it could accelerate spacecraft to a significant fraction of the speed of light, or, if aimed at a planet, sterilize it from light years away. The energy involved is so far beyond conventional weapons that the comparison doesn't really hold. This is a civilization using its star as a tool the way we use a flashlight. The target wouldn't see it coming. The beam travels at the speed of light. By the time the light from the firing event arrived as a warning, the beam itself would already be there. It is the most extreme application of the Dyson concept, and a quiet reminder that any civilization capable of building one would be operating on a level entirely beyond our current comprehension.